Okay, welcome to lecture 3 of chapter 9. Um, you'll be happy to know that this is the last lecture of the course. Our last lecture of chapter 9. We're just going to go on and do a review assignment and then take the exam. And that will be it for this fourth grading period of 2020. A very interesting one at that. So it's basically mixed stoichiometry, and what we're going to be adding with this mixed stoichiometry are two conversions that you've already done. So just like your mass to mole conversions that you worked on in the previous lesson, where you used the periodic table, that's still going to be one of the things you're going to have to do, and probably the most common that you'll have to do. The other two are going from moles to atoms or molecules or formula units, depending on what your substance is. And remember, that conversion is 1 mole is equal to 6.02 times 10 to the 23rd of whatever you have, molecules, atoms, formula units. Remember, atoms are just when you have a single element in its elemental form. Molecules are when you have a covalently bonded compound, usually just all nonmetals, like CO2 or H2O, CH4. And formula units are what the name that we use for ionic substances like NaCl or KNO3. Okay, so that's the only difference there. So that's your molecules or formula units that you see right here. And the other conversion that you've done already is the molar volume of a gas, and that is that 1 mole of any gas at STP, remember that stands for standard temperature and pressure, occupies 22.4 liters of space. Okay, so that is your third conversion. So they're exactly the same as what you did in chapter 3. They're exactly the same as what you did in chapter 7. So 1 mole is equal to the mass in grams from the periodic table. 1 mole is equal to 6.02 times 10 to the 23rd of anything. And 1 mole is equal to 22.4 liters of a gas at STP. Okay, so remember, all of those are equal to 1 mole. The only time you could have more than 1 mole in your problem is when you are using the balanced equation. Remember, stoichiometry starts with that balanced equation. That's how you convert one substance to the other. Okay, so we're only going to do 2 examples. Okay, here's our first example. Here's our balanced equation, CaC2 plus 2H2O yields C2H2 plus CaOH taken twice. How many liters of C2H2? So this is what we are trying to find. We want to know how many liters of that at STP. Remember, that's only for a gas, volume of a gas. Will form from the reaction of 32 grams. So we have a gram amount of this, 32 grams of that, with an excess of H2O. Remember what I mentioned about excess is you don't worry about how much there is. It means you have enough. And when this runs out, this will not, but the reaction is still going to stop because you ran out of one of your reactants. Okay, so you have an excess of water. And water would be a substance where you usually have an excess of it. You have plenty of water when doing chemical reactions. Okay, so in words, just what we're going to do here. We're going to go from grams of CaC2 to moles of CaC2 using the mass from the periodic table. Then we're going to go from moles of CaC2 to moles of C2H2 using the balanced equation and the coefficients. As you can probably already tell, the mole ratio for this one's going to be pretty simple, 1 to 1. But you still need to show that step. I know it doesn't change your answer. And then finally, we'll have moles of C2H2, and we're going to change that to liters of C2H2 using the fact that there is 22.4 liters in 1 mole. Okay, so let's go down here and start with what we're given. All of these are still going to be 3 steps. Okay, 3 steps. Okay, so we have C, A, C2. Okay, so we have grams. So we want to convert that to moles. So grams to moles, we use the periodic table. Okay, so I have my periodic table here, Ca 40.08. And 2C, so plus 12.01 times 2, gives me 64.10. So 64.10 grams. That goes on the bottom in 1 mole. Okay, so grams will cancel out. Now you have moles of CaC2. Okay. Now we want to change our substance. That's where we use the balanced equation. So I look up here the balanced equation, look at my coefficients. For every 1 mole of CaC2 that reacts, we talked about this earlier, CaC2, you produce 1 mole of C2H2. That's called acetylene, or ethylene is another name for it. Okay, so your moles of CaC2 cancel, moles of CaC2 cancel, and you have moles of C2H2. Now we just have to go to liters. So what we did last class was we went to grams again. So we used the mass from the periodic table. Now we're not going to grams, we're going to liters. This actually is a little bit easier because you don't have to do a molar mass as long as you know the fact that 1 mole of C2H2 occupies 22.4 liters of space. So your moles cancel and you're left with liters. That's what you want. So let's do the math. 32 divided by 64.10 times 1 divided by 1. I know it's the same, but still needed, times 22.4. And you get like 11.2 liters of C2H2. Okay, there you go. So grams to moles by using the periodic table, mole ratio from the balanced equation, and then going to liters. Okay. All right, next and final example problem. This is based on the same balanced equation. The CaC2 plus 2H2O yields C2H2 and plus CaOH taken twice. How many molecules of water? So we want molecules, not moles. Molecules, individual units. So right then you can think my answer is going to be large. If you have any sort of volume or mass or whatever, molecules are so little that you're always going to have a lot of those. It's just a counting number. It's like the number of molecules are needed to react with an excess of CaC2. So now this is an excess, okay, to form 100 liters of C2H2. So we have liters of this, and we're going back here. So you can go from anything, from reactants to products, products to reactants. Here we're saying, okay, we need 100 liters of C2H2 in some sort of application. Rare that you need, well, how many water molecules am I going to need? But it's just something to sort of think about. That's why you know how much you want to produce, so how much you're going to need to start with. Okay, so that's kind of what you have here. All right, so start with what you're given, 100.0 liters of C2H2. Okay. All right, so we're at STP. We're not at moles. We can't do a mole ratio yet, so we have to get to moles. So we're at liters, so we're going to use that standard molar volume of a gas. There's 22.4 liters. And again, what's nice about this, it's for any gas. The size of the gas particle doesn't matter with volume because they're so spread out, the size of the molecule. The volume is based on temperature and pressure, not on the size of the molecule. Okay, in 1 mole, okay, mole on top, we want liters to cancel, so that's C2H2. I know it's a pain for me to write these in, but it is good to keep track of your substance because you are changing it in these particular questions. Okay, So now we have we have moles of C2H2, not one. We have to divide 100 by 22.4 to see what that's going to be. Now we do our mole ratio step. So for every 1 mole of C2H2, that's going to go on the bottom because we want that to cancel. 1 mole C2H2. Okay. We need 2 moles of water to produce that. So 2 mole of water. I made my factor label a little small there. H2O, so moles of C2H2 cancel. Okay. Now we have to go to molecules. So if we ask for moles, remember those are 2 very different things. If we're asked to go to moles, we'd be done. For molecules, we continue in 1 mole of any substance. In this case, it's water. Okay, 1 mole of H2O. That's going to cancel. With that, there is 6.02 times 10 to the 23rd. In this case, molecules. Molecule. You're going to be so glad when I'm done with this. Probably not as glad as I am, but pretty glad for writing like this. I have to figure out a new way. There's a way to do your iPad, like the newer iPads with the Apple Pen, and you write on the iPad, it comes up on the screen. But I just don't have that technology yet. Hopefully I don't need it next school year. But anyway, okay, so here we go. Let's do the math. Okay, so 100 divided by 22.4 times 2, and then times 6.02. I have to turn my phone sideways. EE23 hit equal, and we get 5.375 times 10 to the 24th. So that's going to be it. We have 4 sig figs here. 5.375 times 10. Oops, what do we got going here? There we go. 10 to the 24th molecules of water. H2 and done. 5.375 times 10 to the 24th molecules of water. So those are mixed mole problems. So you have homework today on these mixed mole problems. Okay, so check your answers with the provided answer key. Tomorrow, you'll be doing just a review assignment, very similar to how your test is going to be set up, except your test will be multiple choice. And then the last thing for the class is taking the test on Chapter 9. I'm going to make that active starting on Thursday. Okay, so you don't have to wait till Monday, June 1st to take it. If you feel you want to take it over the weekend and get it done, that's your last assignment. Feel free to do that. If you just want to wait, that's fine. I think I put a due date of June 3rd on there so I can get your grades done. They're due around then, 3rd or 4th. I'd appreciate it if you do it before then, but try to get those done. It's going to be 8 problems, all multiple choice. The first 2 are mole to mole. Then you have a mole mass, a mass mole, then 2 mass, and then 2 mix like you did today. So then you choose the correct answer. The 1-step problems are worth 3 apiece. The 2-step problems, like the mass mole and mole mass, are worth 4. And then these 3-step problems are worth 5 apiece. Okay? So that's it. Have a great day, and I will talk to you guys later. Bye-bye.